Okay, so for number 57, I'm reading, it says find the exact value of the surface area obtained by rotating the arc. It's given parametrically. They tell me what x is in terms of t and what y is in terms of t. They tell me it's between 0 and 1 for the t and about the x-axis. Now, granted, I realize there's work down there. If you can follow that and get the same answer I'm getting, good for you. And the bottom line, you really don't need to look at the work. I would say basically, there is structure to it. But I want to point out, if I were on an exam and I were taking the exam, there's certain things I would want to get, and they're called milestones for a grader. Right, so what I'm going to do is I'm going to go to the whiteboard, and I'm going to talk about, you know what, I forgot what number this is, and I'm going to write that down for you. It's 57. I'm going to write that down, 57. So if I were doing this, and I would write certain things down. So I'm going to write x down, and x is equal e to the t minus t. Now, depending, where you go to school, grader may give some credit for writing down some things about the problem. So I'd write down dx dt. That's going to be e to the t minus 1. I'm going to write down y, and what's y going to be equal to? 4 e to the t over 2. I'm also going to write down dy dt. And what's that going to equal? I'm going to say, well, it's going to be e to the t over 2, and then 4 times half, which is 2. All right. Now, a couple of things I got to do with this. I got to, certainly set an integral up for surface area, and I'm gonna, I'm not gonna say it's gonna be a good picture. It doesn't have to be, but I'm gonna start talking about the t over here is between 0 and 1. So at 0, it's going to be, let's see, let me write this down. So when when t is 0, the x would be equal to, let's see, 1. And what would the y be equal to? The y would be equal to 4, right? Now when t equals 1, what do I get? Let's see, x would equal e minus 1. And what's the y going to be? It's going to be 4 root e if t is 1. Kind of nasty though, but I'll be honest with you, it's not that bad. So I'm going to just do ballpark picture over here. I'm going to say maybe up here somewhere. And then, x e to the minus 1, I'm going to say like maybe over here somewhere. And there is some connection between that. And I'll rotate it like this over here. So I'm definitely seeing something, all right? And granted, it may not be the best picture, but I'm not really looking for a good picture. They didn't ask me to draw a picture anyway. So I'm going to write this down. And what I'm going to do is I'm going along the T's now. All right? And I got to do something over here. And what I noticed about this over here, there's going to be a strip that's being rotated around, and that's going to be 2 pi. And the circumference of that strip actually has to do with the y value. And what's the y value going to be? 4e to the t over 2. Now, these t's are going to be starting at 0, and they're going to be stopping at 1. Now, what happens next is going to be, by the way, this is the surface area of that rotation. I'm just going to call it S. All right? Now, what goes over here inside these things is going to be the, the dx dt squared. I'll write that down now. So that's e to the t minus 1 squared plus 2e to the t over 2 squared. And then it's going to be dt. Okay, if this were an exam question, I would be doing something now. And what I'd be doing is, I'm going to erase this business. I don't really need it. This was to help me, to understand the picture of it. I don't need the picture. Right? I want to get rid of distractions from the grader's view, by the way. Right, so what do I have down so far for the grader to look at? Yeah, I certainly have the derivative of x down, and that's a good thing. I have the derivative of y down. And by the way, I've got this down. And this is important I have that down. Now, what I would do now is I would look at this thing and say, this looks like it might be a lot of work for me. I don't know if it is, by the way, but I would go to another question, and I'd come back to this one in the blue book. I would certainly leave space for it, but I want to continue it now. So someone says, well, how do I know something will take a long time? Well, so far, it hasn't taken that long to put this down. So let's write S down. I'm looking at it, and I see 8 pi. I'm pulling that out. That's going to be 0 to 1, and I see e to the t over 2. I see this really long root problem over here, and I'll put dt down here. I'm going to square that. That's going to be e to the 2t. That's not so bad. And then you're going to get minus 2 e to the t. And then you can get plus 1. And then what do you get? You get plus, well, 2 squared is 4. And then, when I square that, it's just going to be e to the t now. All right, I'm suspecting this is going to work out pretty nice, by the way. There's going to be no real special tricks over here. And then what do you get over there? Let's be real careful about this. You get e to the 2t, and then I get plus 2e to the t plus 1. Looks like a perfect square. Let's keep going. And you can get e to the t plus 1. Let's see if that works. Yeah, like a charm. And that's squared, by the way. So I'm going to keep writing it over and over again. E to the t over 2. This is 0 to 1. That's going to be e to the t plus 1 dt. Wow, I'm getting really close now. Things getting smaller and smaller as I move forward. What do you get over here? 8 pi. And then you're going to get an integration from 0 to 1. And that's going to be e. Well, t over 2 plus t is going to be 3t over 2. And then it's going to be plus e to the t over 2 dt. Let's see if I did that right. Yeah, I think I did okay. I'm going to integrate now. And that's going to be e to the 3t over 2 times 2/3. All right, let's keep going. Plus e to the t over 2 times 2. Limit integration 0 to 1. All right, I got to write this down now. 8 pi. I'm going to do the 1 first. That's going to be 2e, and you're going to get 3/2 there. Then you can get plus 2e to the 1/2. Then you can get minus, this is 0 by the way. You're going to do the 0 now. So it's 8 pi, and you're going to get 2/3. E to the 0 is 1, plus 2. Well, it's not so bad. It's working out. And I'm going to get a common denominator. And then you get what? 8 pi. And let's be careful about this. You're going to get 2e root e. First term. Then you're going to get 6 root e. Then you're going to get, again, I have come down to 3, by the way, minus, I've already factored the 8 pi out, by the way, minus 2. And then it's going to be minus 6. Clean up a little tiny bit, and get 8 pi. Let's see, 2e root e plus 6 root e minus 8 over 3. All right, I don't have the key in front of me, but I want to point out it's a long problem. So remember this, on exams, what you're going to be doing in a blue book is trying to write down what I call milestones, like derivatives, because you're going to use those derivatives. It's really nice if you get the integral down, right? It's really nice if you can start to simplify the integrand. It's really nice if you can integrate. It's really nice if you can evaluate. If you're going to make a mistake, though, make a mistake towards the end. Thank you.